Hello and welcome to Subnetting Video 7. In this video, you'll see how to find all the subnets of one network when there are less than 8 subnet bits. For this example, we'll use IP network 128.200.0.0 with a mask of 255.255.224.0. As for the objectives, you need to learn a process to find the answer to this type of question, and we'll just show an example of that process. We'll find all the subnet numbers of a single classful network in this process, and we'll identify the zero subnet, which is the numerically lowest subnet, and the broadcast subnet, which is the numerically highest subnet. So let's jump right into this example. We're using IP network 128.200.0.0, and by definition, since it's a Class B network, we know there are 16 network bits in the structure of these addresses. Now the mask tells you how many combined network plus subnet bits you have. And with a mask of 255.254.0, you've got 19 total network plus subnet bits, which leaves you 3 subnet bits. And it defines 13 0 bits in the mask, so we've got 13 host bits. So we'll write that down to the side and refer to that later. Then we want to mark the interesting octet. So we write down the mask in the top row, and we notice that the third octet has a value that's neither 255 nor 0. So we'll go ahead and put a nice dark rectangle around that third octet as a reminder of where all the interesting work is going to happen. For the last bit of preparatory work, we want to calculate the magic number. Now the magic number is calculated with a 256 minus the mask's value in that interesting octet. So in this case it's 256 minus 224, or 32. Now with all these bits of information gathered around, let's go ahead and write down the first subnet number in this network when using this mask. To do that, we simply copy. We copy the IP network number down into the next row, 128.200.0.0. That's the first valid subnet number, and it's also called the zero subnet. It's called the zero subnet for several reasons, but today you can just think of it as the subnet number whose number is an exact replica of the IP network number. Now that we have that first subnet, the zero subnet, written down, finding the rest of the subnets just takes a little bit of addition. The next few subnets, we just copy the 3 uninteresting octets, the octets outside the box. So the next subnet's going to be 128.200.something.0. Then we add the magic number to the previous subnet. So we add to the previous value 0, a 32, and we get 32. So the next subnet number is 128.200.32.0. To get the next subnet number, we do the same thing. We copy the 3 uninteresting octets. So we copy down the 128.200.something.0, and then we add the magic number there in the third octet for 32 plus 32, or 64. So our next subnet, 128.200.64.0. We keep repeating the process. Copy the 3 uninteresting octets, add 32 in the third octet. 64 plus 32 gives us 96, of course, for a next subnet number of 128.200.96.0. And you can continue through this process, obviously, so we'll just show those on the screen and not talk about every step. Keep adding the numbers for 128.0. Copy some more octets, adds 32 again, 160.0. Repeat it again. We'll get 192.0. Repeat it again. Get 224.0. At this point, it turns out we're almost done. But you need to know how you're done when you don't have the video showing you that you're done. So let's keep going through the process. Let's copy those next 3 uninteresting octets, and then we're going to add 32 in that third octet again. So 224 plus 32 gives us 256. So the process as it's described here says, oh, if you make your addition in the interesting octet and end up with a 256, well, you can't have a 256 in an octet of an IPv4 address. It's out of range. So we want to mark that out and say that's illegal. We shouldn't have gone there, but that's our trigger, so we know that we've gone too far. So we mark that out. In the previous row in the table, that's the last valid subnet, and that also happens to be the broadcast subnet. Now let's pause and take a look at the list as a whole. We've got the zero subnet at the top and the broadcast subnet at the bottom in a table. Then if you remove the table and push the numbers together, we can see them a little more easily. We see 8 subnets, And we see a pattern there in the third octet. Each is a multiple of 32. There are a total of 8 subnets. We should know that because earlier we saw that there are 3 subnet bits, so there are 2 to the third, or 8 possible subnets. The first one being the 0 subnet, and the last one numerically being the broadcast subnet. So what should you do from here? Well, you need to practice until you master the process. The book has some practice suggestions, including an appendix on the DVD that has additional practice problems. You should wait to do the next video until you practice more like this one, where there are less than 8 subnet bits, which keeps all the work inside one octet, because video 8 will show you how to do the work in multiple octets.